In this video, we are going to study a very interesting problem. For example, let's try to find the equation of the tangent line of y equal x plus 1, x squared plus 2, and x cubed plus 3. So there are four functions multiplied at x equal 1. So what we can do, we can use the product rule as usual, but we can notice few things. The first thing we notice is at x equal 1, you can see that this term is 0. When you plug in x equal -1, this term is 0. So because of that, what we're trying to do is we try to isolate that term before we take the product rule. So we try to write this one as x plus 1, and then we have the rest of the terms, x squared plus 2, x3 plus 3. So now what we can do, we can take this one as u and everything else as v. So you will see what will happen when you take the derivative now. So the derivative, which is u prime v plus v prime u. So u prime, you can see in this case is 1 times the rest is x squared plus 2 x cubed plus 3 plus the next term is v prime. So we just write the term, but we are not going to find it. You will see why we don't want to do that. So we just write the prime, the derivative of that, times x plus 1. Now what we're going to do, let's evaluate the derivative at the point -1, because we need the slope of the tangent line. So if you want to find the equation of the tangent line, we need the slope of the tangent line. So the slope of the tangent line is y prime evaluated at x equal -1. So when you do that, and then you can see this term going to be -1, the first term will be -1 times, when you square -1 it is 1, so 1 plus 2, and when you square -1 it is -1 plus 3, so that final term is okay. The second term I'm not gonna substitute because we don't know the derivative yet, so we just leave it like that. Just leave it like that. And the derivative of this one, we're going to say evaluate at x equal -1, and then you can see this term is going to be 0 because at -1 this one is 0. So that's the whole point here. So that means because of that, this whole term get cancelled out. So that means you simply get the slope as -6. So that is the benefit of isolating that term, because you can see that that term is going to be 0 because of the special choice. Now what we can do is we're going to find the y value. Now to find the equation of the tangent line, we can find the corresponding y value at the y equal -1. So you can see that because of the x plus 1 factor, this is going to be 0. That's the y naught value. And then we can write the equation of the tangent line. So the equation of the tangent line is use the slope point form. So it's y minus y naught equal m x minus x naught, and then we're going to plug in. We know that y naught is 0 equal m is -6, and then x minus -1, so we're going to x plus 1. So when you simplify, you're going to see that y equal -6x -6. So that is the equation of the tangent line. Now you can actually see the graph of this one. This is the graph of the curve and the tangent line, and you can look at you can visit the link given here to access the actual graph on the Desmos website. Now let's try to do some practice problems. Now try to do these problems as practice problems, and you can see that you can use the exact same method, and you need to be careful which term you're going to pull out. For example, in the first example, you're going to pull out this term because that's the term going to be 0 at x equal 3. And similarly, you can find the corresponding term, which is going to be 0. Once you pull out that term, and you can see it's very easy to find the derivative, so you really don't need to find the derivative of the rest of the terms. Okay, thank you.